We are going to do a quick review of Chapter 1, Section 4, just because it's part of this huge life science unit, and I want to make sure you don't forget everything, and you still have a reference to go back and remember all that was covered before the craziness happened, and we were at home. So, Chapter 1, Section 4. We've got classification systems. Biggest thing you're going to have to remember from this slide is who Aristotle was. He was one of the ancient Greek philosophers who came up with a really early model of classification. He's the one that would have classified things based on their outward appearance, because there was no type of technology like microscopes. We didn't know about DNA, any of that kind of stuff, which is why he would have put the organisms of birds, bats, and butterflies in the same category because they all had the ability to fly and had wings. We now know that humans have more in common than any of those other creatures do with bats because we're both mammals. A whale has more in common with a bat, oddly enough, because it is also a mammal. Birds are again birds, and butterflies are a type of insect. There wasn't a universal type of classification system at this point either, which also made things super confusing, because if one person uses one way of organizing and one person uses another way, that again puts a barrier of communication up. This brings us to what we use today. This type of classification we call taxonomy, not taxidermy. Taxidermy is when they put the stuffing in the dead things. Taxonomy is how we classify living organisms today. This ranking of domain, kingdom, phylum, class, order, family, genus, and species last is going to go from domain being the largest, broadest category down to species, which is the most specific and smallest category. In domain, you may have every single thing that's a eukaryote, from a rose to a human to a banana slug to a dolphin, a snake, turtle. All those things are eukaryotic organisms. And as you go down each category, it's going to get more narrow, more specific, until you get down to just one individual species at the species level. You can use the Dear King Philip cried out for goodness sake, Dear King Philip come over for good soup, or Mr. Matlock's awesome dumb kids play checkers on fat guy's stomach to kind of help you remember and memorize this, because it will come back to haunt you later this week, I promise. Now, with scientific names, I understand they look completely and totally crazy, and we basically use dead languages of Greek and Latin to name them. You may be wondering, why? This is dumb. This is stupid. Cat. It's 3 letters. We all know what a cat is. Why on earth are we calling it Felis domesticus? Well, that's because if you went to China and someone that speaks Mandarin, cat probably isn't cat in Mandarin. If you went to an African country where they speak Swahili, cat isn't cat in Swahili, okay? There's a language barrier there. Cat is going to be a common name that we use and we can understand. So using these scientific names gives a universal playing field of using Greek and Latin that every scientist in every country, everywhere is going to understand. And this 2-word naming system is known as binomial nomenclature. The word is scary and obnoxious and huge, but it's its own definition. The prefix bi means 2, nomial means name, and nomenclature means naming system. So the word is its own definition. It is a 2-word naming system. The first word is always going to be the genus, and the second word is always going to be the species. So if anyone gives you a scientific name, regardless of whether you pronounce it or you know what organism it is, you'll always know those 2 characteristics of the genus and species. Canis lupus. Canis is the genus, lupus is the species. Tursiops truncatus. Tursiops is the genus, truncatus is the species. Drosophila melanogaster. Drosophila is the genus, Melanogaster is the species. Again, you don't have to understand what those words mean whatsoever. You don't have to know how to pronounce them. You just need to know the first word is the genus and the second word is the species. And again, the farther down that classification tree you go, the more related organisms get. Also, if two organisms share a level of classification, that means they also share all the levels above it. So let's go back and look at that for a second. If two organisms are in the same family, that means they're also in the same order, class, phylum, kingdom, and domain. If two organisms are in the same phylum, that means they will also be in the same kingdom and domain. You can assume every level above it. You cannot assume the levels below it. You will also need to know that for this week. So back to why we use these crazy names. I already mentioned to avoid mistakes in communication. One of my favorite examples to use is the mountain lion. Some people may just call it a mountain lion. Some people may call it a cougar. Some people may call it a puma. There are lots of common names for the exact same creature. And I use the example with my class. Imagine having like a foreign exchange student come over that was from Portugal and speaks Portuguese. And you've got a house cat. And you're like, this is my cat. And they're like, oh, yay, cute, cuddly, I love it. Then you take that same person camping. And you hear that freakish scream of a mountain lion at night. And you tell them, oh, big cat. And they go outside the tent, and they're all like, kitty, 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 kitty. And then the newspaper headline the next morning is foreign exchange student dead at camping trip. Okay? It causes some issues. We need to have a common way of communicating that bridges these language barriers. Second, organisms with a similar evolutionary history are classified together. This is where Aristotle didn't have enough information, where we, with our technology and our knowledge of genetics and DNA, we have this information, because this goes with knowing that a whale, a bat, and a human are closely related because we're all mammals, instead of a bat, a butterfly, and a bird being related because they all have wings. It kind of shows some of those family trees. They can give descriptive information about the species. These Greek and Latin names have meaning to them, just like how we broke apart the words binomial nomenclature, and each part of those words had a meaning. Same thing with these scientific names. Your textbook uses Acer rubrum and Acer sacrum. These are types of maple trees. Acer rubrum is the red maple. Rubrum literally means red. Acer sacrum is the sugar maple. Sacrum means sugar. Felis domesticus and Canis domesticus. Hopefully you realize Felis sounds like feline, and Canis sounds like canine, and domesticus sounds like domesticated. Well, it tells us that a cat is a domesticated feline and a dog is a domesticated canine. So they give us some information about the species. Sometimes they're named after where the species was originally found, or even the scientists that found it. And fourth, it is universal. So it allows us to classify information easily and efficiently. In science, we love efficiency. We don't want to waste time, resources, because that usually translates to wasting money. So being able to access stuff easily, communicate, get work done is awesome. Dichotomous keys. These are a detailed list of identifying characteristics that include scientific names. So you're going to have a number, and each number is going to have two choices. And you're going to look at your lovely little organism, and you're always going to start at number 1 no matter what. And you are going to read your two options, pick which of the two options applies to your organism, and then follow the directions. Okay, that's the key important part. Follow the directions. Don't go 1, 2, 3, 4, 5 because common sense is logical to go 1, 2, 3, 4, 5. Start at 1 and then go to whatever crazy number it tells you to go to. So let's do one of these for example. Let's look at H. Needle leaves or non-needle leaves? That is going to be B, non-needle leaves, which tells us to go to number 3. We'll read number 3. Is it a simple single leaf or a compound leaf made of leaflets? It is a simple single leaf. So we're going to go to number 4. Does it have a smooth edge or a jagged edge? That is a jagged edge. So we're going to go to number 6. Is the leaf edge small and tooth-like or the leaf edge large and thorny? That is a holly leaf. Okay, so it is B. It is large and thorny. And that's how this is going to work. These are some of the simplest, easiest things that we can do. And if you want to have some fun and do the extra assignment for people that don't have internet access, I told them to grab 10 random tree leaves, bushes, grass, flowers. There are all sorts of stuff growing in your yard right now probably. Grab like 10 of those to try and make a dichotomous key and see if you can organize them. Or if you and outside don't mix well, grab 10 little small random items from your home and try to make a dichotomous key, if you get that bored. Species is a key definition that's going to come back to haunt you over and over again with biology. It is a group of organisms that can mate and produce fertile offspring. Fertile is the key word because if they're not fertile, they can't keep making more of their species, which means once that last member dies, it's extinct, dead, no more, finished. Hybrids are different. Ligers and zonkies, their genetics, they're not a natural combination. So the way their genetics line up is they are sterile. You cannot mate 2 zonkies and get more zonkies, just like you cannot mate 2 ligers and get more ligers. In order to get more zonkies, you have to mate a donkey and a zebra again. In order to get more ligers, you have to mate lions and tigers again. And yes, these are all real organisms. You can look them up. They're not fake. That liger's name is Hercules, and I believe when we looked him up, he lives in North Carolina, I do believe. So these are real. Just remember, a species is a group of organisms that make fertile offspring so they can keep the species going. And how to write scientific names, which I'm kind of picky about. Because when you see them written in this PowerPoint, you're going to notice they're in italics, which is that slanted looking font. But when we write, we don't write in italics. So when you handwrite scientific names, you're going to underline both words separately, like how Homo sapien here is in the example. Homo is underlined separately and sapien is underlined separately. Don't just draw one line underneath both of them. And the first word, which hopefully you remember is the genus, is always capitalized. You do not capitalize the second word of species. And that's it for this little quick section. Hopefully I didn't run through that too quickly. And if you guys have any questions or comments, contact us through Flipgrid, Google Classroom, or all the other 500 ways we've got set up for you guys to reach out to us. Hope you guys are staying safe and healthy, and talk to you soon.